Okay, we are going to talk about atomic structure. Now, atoms are not the most fundamental of particles. You can actually split them down into smaller bits, and we need to know what those bits are. Okay, so you've probably seen things like this written in the periodic table. So that's He is the symbol for helium, and this number 2, this is called the atomic number. And this one here at the top here is called the mass number. Right, and that gives us some indication of what subatomic particles are present in the atom. Now, the 3 subatomic particles we need to know about are here: the proton, the neutron, and the electron. Okay, so what we're interested in each of those particles are its mass and its charge. Now, we're not going to measure the mass in grams because the proton weighs such a small amount in grams, it wouldn't be very convenient. We're going to give it a mass of 1 unit. So a proton weighs 1 unit, a neutron weighs almost exactly the same, that weighs 1 unit as well. An electron has hardly any mass at all, it's about 1/2000th the mass of a proton and a neutron, so we can just simplify that and say 0. For all intents and purposes, they've got no mass. Now, charge, this means the electric charge. So electric charge comes in 2 varieties. You can have positive and you can have negative. And the proton has got a charge of +1. The neutron doesn't have any charge at all, as its sort of name would suggest, neutral. And the electron has got a charge of -1. So it's exactly the same amount as the proton, but it's the opposite. So that's the properties, the fundamental properties of the 3 particles, and we need to know how they're arranged. Well, the proton and the neutron are arranged in the nucleus. Now, the protons are drawn as a little red dot there. So in the case of helium, you're going to have 2 protons. We can tell it's 2 protons because that is given by the atomic number. This is the number of protons. And the number of neutrons, well, that's given by this top number here. Well, that's not the number of neutrons. The mass number, that's equal to the number of protons plus the number of neutrons. So if there's 2 protons in the case of helium, 4 minus 2, there must be 2 neutrons. So that is the nucleus of a helium atom. Now, the electrons are not found in the nucleus. They're found and they orbit around the outside. Okay. So, and this is definitely not to scale. So the electrons orbit away from the nucleus. Now the number of electrons is that helium will have 2, because the charge is always got to be neutral. And see, we've got 2 protons there. So that's going to give us +2. The neutrons don't have any charge, so ignore them. And the electrons, well, you've got to have 2 negative electrons to cancel out the 2 positive protons. So the overall atom is neutral. So we've got 2 of those. And the electrons are arranged in shells. We won't talk about them in this video. Talk about them in the next video or so. But they do orbit the nucleus. Now, just to give us an idea of size, the nucleus there is about 1/10,000th of this radius here, the atomic radius. So you can see the atom is mostly empty space. The electrons are a long way away from the nucleus. So if you roughly the scale is, if you have it's not exactly right, but I think if you got a football on the center circle of a football pitch, if that was the nucleus, then the electrons would be orbiting around the stands. That would be the kind of scale we're talking about. So tiny little nucleus, that's called the nucleus, made up of protons and neutrons, and then you've got electrons whizzing around the outside. The number of electrons is given by is the same as the number of protons in the neutral atom. So let's have a look at the first 20 elements in the periodic table then. Okay, so here we've got, I'll do helium, we've done helium, so let's do that. So we had atomic number 2 there, so you've got 2 protons. The number of neutrons is the mass number minus that, so it's 4 minus 2, so it's 2 neutrons. Lithium, well, that would have 3 protons, 7 minus 3, so and 4 neutrons. So it's got more neutrons than protons. I've done hydrogen last because it's a bit of an unusual one. So atomic number is 1, so that's 1 proton. And the number of neutrons, 1 minus 1, so it's got no neutrons. And that's the only element that doesn't have any neutrons in its nucleus. All the other ones do. And we just do the first 20, so beryllium, so that's going to be 4 protons, that's going to be 5 neutrons. Again, we're just subtracting the atomic number from the mass number. Boron, that's going to be 5 and 5. Carbon 6 and 6. Nitrogen 7 and 7. So you can see so far the number of neutrons is roughly equal to the number of protons. We've got 8 for oxygen. Go to fluorine. We've now got 9 protons and 10 neutrons. Neon, 10 protons and 10 neutrons. 11 and 12 for sodium. 12, 12, 13, 14, 14, 14. Then we've got 15 and 16, 16 and 16. So very often you'll see the number of neutrons is equal to the number of protons, particularly for the smaller atoms. Get to chlorine, so that's 17 and 18. Argon, 20. Argon, that should be 18 there, sorry. So that's going to be 18 and 22. So that's quite a few more neutrons than protons. Potassium, 19 and 20. Calcium, 20 and 20. Now, that's the first 20 elements. And usually the number of protons and the number of neutrons are about the same. Maybe sometimes the number of neutrons is 1 more or so. But as the atoms get heavier and bigger, you can see that they tend to have a lot more neutrons than protons. So look at iodine, which has got atomic number 53. So it's got 53 protons. So that means it has got 127 minus 53. It's got 74 neutrons. It's got a lot more neutrons than it has protons. And lead, which is a big atom, 82 protons. And that's going to be 207 minus 82. So that's 125 neutrons. So as atoms get bigger, they seem to need more neutrons to hold the nucleus together. But again, just to summarize, don't forget, let's take lead as the example. This bottom number, atomic number, which is equal to the number of protons. This top number, it's called the mass number, and that's the protons and neutrons combined. And how do we work out the number of electrons in a neutral atom? So the number of electrons is equal to the number of the protons. The protons and the neutrons are in the nucleus, the tiny nucleus, and the electrons are whizzing around the outside.